Hi Rajni, we'll wait for a few other peoples to join, then we can get started.
Okay, sir.
Okay. Very low strength today. Shit. Not able to add. Acha. Good evening, everyone. Um, Today we don't have much to cover actually, as new weeks in NPTL was not released. So there is this week three sessions is going to cover the previous things we have covered. Okay, some few questions I have uh, got it, which we have not covered before. Okay, those are to be done, and then it is finished. Okay, these are also very easy. Okay, and so hope you understand and enjoy the lecture. um, is everybody can everybody hear me? Okay, Shanti, can you not speak up? Yes, Shanti, you can say. Maybe you're not able to unmute.
Yeah, maybe I could.
Yes,
Uh,
so audible everything.
yeah, yeah, it's audible.
Okay, okay, let's get started then. So so the we need to find the bias of the model. Okay, and for that what we need to do is how to calculate that is is calculate the y prediction minus y actual, okay, for every one of them. Okay, so what do you get? 4 minus 5 is minus 1, and this is also minus 1, then it is minus 2, and then it is 1, then it is minus 2. So this is the array of values of y prediction minus y. Okay, you have to take average of these values. Okay, so how much does become? Minus 4 minus 5 minus 6 minus 5 by total number of values is 5. Okay, so answer is minus 1, so bias is minus 1. Okay, got it everybody?
1 second, please. Huh? 1 second, I'll calculate.
Okay, okay, see the slide. So many people have joined. I should, I think, repeat. Okay, so as I repeat, it's like there isn't much to cover today, nothing new here today. We are just going to do the previous things. So, as we already covered much of it, okay, so we need to calculate the bias of the model. Okay, for that, what we need to do is y prediction minus y. We need to calculate the list of it. Okay, and take the average of it. Okay, sum divided by total number of observations, so minus 1 is the answer. Yes, Shanti.
Yes, yes. Answer is -1.
Yes, so as I said, quite easy. Okay, so let's continue. Okay, for variance what you need to do is calculate the y prediction minus y square. Okay, and sum over that, then you can get the variance. Okay, so means mean over that. Okay, okay, so what you do now is get to the data and mean square these values up. Okay, so that is going to be 1 1, I think 4, next 4, and then 1, then 4. Okay, 1 1 4 1 4. Okay, you have to sum this up, so 4 2 8, 10 11. Okay, option is not there, I think, the thing we want. So it is 2.2, so maybe none of these. 2.2 is the answer we are getting. Okay, variance formula is expectation over, sorry, variance formula is expectation over, okay, y minus expectation of y whole square. Okay, so this is it. Okay, and so that is how we do it. Okay, expectation is the mean. Okay, here, um, okay, maybe the options aren't that great, none of this should be the answer. Okay, and so next question is this one, linear regression. Okay, we need to find the parameters of the model. So how do we define linear regression? A, so this is the line I'm trying to fit. Okay, so A and B are the parameters we need to find. Okay, next what we do is uh, next we write the uh, mean squared error. Okay, so how do I write it? Ax plus b minus y values okay, square, okay, summation over this xi and yi, okay. So this is our mean squared error, okay. So next what we do is to take the derivative, okay, with respect to a and b, okay. So that will be partial derivative del m by del a, okay. So to minimize we need to take the derivative, right, and put the derivative equal to 0, okay, to minimize the error. So that is, then we can have a least square fit, okay, least square error fit, okay. So we'll take it the derivative, okay. So 2 comes over summation and a comes over here, no, not a. So it is 2 and multiplied xi, okay, okay, how, and we put that this to 0, okay. Actually xi will not come out of the bracket, sorry, it's dependent on I, okay. So what this will become is summation xi, okay, this. So what we get here is a x I summation xi square plus b xi summation over is equals to summation over yi xi, okay. This equation we have got it clear, everybody clear? We are taking
Yes,
derivative with respect to
yes,
a.
yes. 2, like x square derivative 2x, then we have to write all
No, no,
this.
no, no. Yes, yes. Means
Yeah,
like
the upper one is x square, na? Like the
yes,
first
yes, yes, yes.
equation. Huh.
This is like a
So
with chain rule. Yes.
accordingly, we have to multiply each terms with sigma x. So,
Yes.
oh, thank you.
So this is the first equation, and next, next what we need to do, we need to take derivative with respect to b. Okay, and so we'll taking that. Okay, so again 2 comes ahead, and summation over with respect to b, as you can see nothing will come, okay. So this will become axi plus b minus yi, and this equals to, this sets to 0, okay. Putting the summation over all the examples is equals to this. So these are the two equations you have got, okay. Okay, so two equations, two variable, our two variables are a and b, okay. So we need to find the two variables, okay. So what is the idea now? So idea is like this, okay. So first x values you are given, okay. So what you need to do is create the table of x square values, okay. Next what you need to do is create the table of xy values, okay. And what more do you need? X values also given, okay. So write the x values, y values as well, okay. Calculate the sum of these, this row sum, okay. Write this down here, write this down here, write this down here, write this down. So this is summation over xi square, this is summation over xi yi, okay. This is summation over xi, this is summation over yi, okay. So just put these values in the equation, you can get two equations on a and b, so you can solve that, okay. Clear everybody? You can do it now. Clear?
Sir, sir, could you please explain that once again?
Acha. Okay, let's start again. So first we have this. We have to fit this curve. Okay, and the curve fitting theory states that uh, we have to fit the curve such that the our mean squared error. Acha. This has to be divided by number of examples. That is n. Okay, but actually it is constant of I, so it doesn't actually matter in the differentiation process. But for technical correctness has to be mean. Okay, mean squared error, this is squared error. Okay, and this is mean of its sum, and then divide by total number of examples. Okay, so this is it. Okay, mean squared error is needed. Okay, because we need to minimize the error. Okay, this mean squared error. So for minimizing, what we are doing is that there are two parameters a and b. We are taking derivative, partial derivative with respect to these two parameter, so that, and putting them to 0. Okay, and if you take the second derivative, you will see that this is negative. Okay, this is positive. Okay, if you take the second derivative. Okay, let's take that as well. uh, so actually it is also needed, I have skipped that. Okay, second derivative is also needed. Okay, to prove that we are getting a minima. Okay, so we will take the second derivative with respect to a here. So it becomes 2, and what do you get here uh, with respect to a, right? So it is going to become summation over xi square. Okay, rest will become 0. Okay, rest will become 0. So this is it. Okay, and this is positive, that's for sure. This is a sum of squares. Okay, this is 2.
Sorry. Which one will be zero? Why the other terms will be
Other
zero?
terms, as you can see, we are differentiating with respect to a, so
Okay,
this is
okay,
b
huh.
independent of a, yi is independent of a
Constant.
as well. Yes.
Okay.
So why is this necessary? Second derivative states that
Constant.
whether means the first derivative states the critical point. Okay, the
Mm.
second derivative says the critical point will be minima or maxima. Okay, we need the minima here. Okay, so if the second derivative is positive, it means it is a minima. Okay, so it is positive, right? uh, so this is a minima, we have got one minima. Okay, so you
So here we need to put all the values of x and corresponding values of y one by one.
no, as you see,
Summation.
so first what you're doing is we write this, okay, in the equation form. Okay, okay, and then with respect to b we do as well. Okay, we're getting this. uh, so then we calculate the values. As you can see, xi square is needed. Okay, so first we write the x square values here. Okay, then sum these up. Okay, that is summation of xi square. Okay, got it? So like that we have to do it for every values. Okay, clear? Not clear?
Xi square, then summation of xi yi. Then after that, what you have written?
Summation
Summation
of
of y
xi
xi, and after that summation of
yi.
y. And when all of these summations came, then after that we need to
Just
add
put
the
the
values.
just you see xi square, summation of xi square is needed here, just put the value
Oh,
here. Okay, summation of
okay.
xi is needed, just put the value here. Summation of xi yi is needed, just put the value here. Okay, clear?
And what are the values of a and b?
A and b is the value that we need to find. Okay,
Find out.
this is the a values. Okay, this is the b values that you have to say. Okay,
So when we will put those values, then there's a plus in between. How we will find a and b then?
the thing is
Two
that we have
equations.
two
Two.
equation and two variable a and b, so from that we can calculate, right? Solve the two equation. This is another equation. Okay, this was one equation, this is second equation.
Okay, with these two equations, we will able to find it.
Yes.
Okay.
Got it? Clear? Clear, right?
Okay.
Okay, on to the next question. So this is the question of the variance bias variance trade-off. Okay, uh, so so bias model is the simple model. Okay, and variance, when high variance is there, then it is a complicated model with high complexity. Okay, model complexity is high. So okay, so that is the difference. Okay, so high variance and low bias is a complicated model. So it can be simple to understand the pattern of the data. So it is not correct. Okay, it will be complicated model. An excellent performance in the training data, but significant decrease in performance when evaluating the test data. This can be the answer. Okay, model fits the test data better. Wrong. Okay, model becomes less sensitive to training data. Wrong. More sensitive to training data. So this is the answer. Okay, clear.
Okay.
Hmm. So so arithmetic average of the n matrices. Okay, so this is the answer. Okay, the sample covariance. Okay, sample variance. Okay, so this is the likelihood. Okay, so what we'll get is 1 by n summation over xk minus mu. Okay, this is the real expression. Okay, from notes I think you can do it. And this is simple question as well. Parson
Sir,
window.
please, sir, sorry to disturb you. Please explain this equation now. 1 by n summation of x
This
t
is
or I.
so this is the okay,
Okay, good.
and
This
this
one
is
I could
transpose
see.
of that. Okay, but
For
derivation is
trans.
complicated. I don't think we should do it here. Okay,
No, no.
I
Okay,
think
sir. No, no.
derivation is there in the notes, I think.
Yes, yes.
Okay, if you say so, you can do as well, derivation part. Okay,
The transpose is written like x1
this is
with weightage
xk.
of u. Xk. Okay, xk minus u.
Hmm.
Okay.
Okay, so let's move on. The first is that as you as you number the as you reduce the number of samples, okay, what will happen is that the variance will increase. Okay, because uncertainty increases. Okay, so the variance actually increases. Variance does not reduce. Okay, if you maximize the window width, okay, then you'll have more number of samples. Okay, so the variance will reduce. Okay, so this is the right answer. Okay, and so smoothing the density function, density distribution, what will happen is that means like then you are not using the true density. Okay, it will reduce the variance. Okay, but what will happen is that you're not using the true density. Okay, so it will build different estimate. Okay, so this is the how you do it. Okay, uh, so next question is this one. So maybe little unintuitive question. What are they trying to say? Okay, so our this kernel function. Okay, that is from the notes. If I open So kernel function here is the kn one, okay, but they have forwarded in a way that they have not used the n and h factors, okay. uh, so for us it is important to consider that. So kernel function, this one dependent on y, okay, is equals to 1 by nh, okay, and summation of I k y minus xi by h, okay. As you can see, the same expression, y minus, okay, xi are the different points, okay, y is the central location, okay, divided by h, okay. So it is written as it is directly proportional to, means it is exponential form, okay. So what we get here is the exponential of minus y by n, y by h, okay. So we can write is that so the k here is the proportional constant, okay, and this is exponential of minus y by n h. Put the value of y and h, k into e to the power minus 2, okay. So this is the answer actually. So this becomes equals to 0.1353, okay. So the function that kernel function that you're given, it is written as exponential, okay, like this, okay, and so just put the values. K is the proportionality constant here, okay, so you get the answer like that.
Sir, how 0.135 is the answer?
I mean like e to the power minus 2 actually. Let me check it
And
again.
what is the value of k here?
K is
We
the
need to put.
proportionality constant. As you can see in the all the options, K is there.
Hmm.
K is a constant value, any value we can take, I
Hmm.
think.
So, but how we can find that it's 0.1353 k is the answer?
It's like
K
you
is multiplied, na sir. E to the power minus 2 is
you
only
have to use a calculator.
0.1353 multiply with K. That is
E
what.
to the power minus 2 value you can check, okay. So that is the answer.
Okay.
Calculator you can use, okay. And last question actually, a simple one overall. So the idea is that so you're given that probability density function, or the kernel function as you say, is a Gaussian one, okay. So the form of the Gaussian is 1 by 2 this, okay, sigma e to the power minus x minus xi square by 2 sigma square. And now you can see that Gaussian function with sigma equals to 1 is given, okay. Sigma is 1, you can remove it, okay, or you can use the this one, okay. So this is it, okay. So this is our density function with we are estimating at x equals to 3. So use x equals to 3 now, okay. So now what you're going to do is that, if you can remember from here, okay. So what we will do here is that we so this is the volume as you can given, so you can understand it is like and the number of probability density have to be summed over and then divided by the number of data given, okay. So what we need to do is we are going to divide by 5, and you have to calculate this value 5 times for each of these, okay. First is 2, As you put 2, it is e to the power minus half. Calculator has to be used here, okay, no other way. E to the power 2.5, so that is uh, minus 0.25 minus 0.25 by 2, okay, like that. So keep doing it, sum over and then divide by 5, you get the answer. Okay, answer is this one. Okay.
Sir, first one will be e to the power minus 3. Within the bracket, minus xi here is 2. So 3 minus 2 will be 1. Na? So
Hmm.
it will be by half.
By
It is written.
but divided by half is
Oh,
also
by
there.
2. Acha, acha. Okay,
Okay,
okay.
so e to the power minus
Uh,
half. You have to just use the general
that formula.
Gaussian
Yeah,
form.
yeah. Sorry, sorry.
So like if you thought that where I am getting the Gaussian distribution, so Gaussian distribution is this one. Okay, so you have to put the value of sigma equals to 1. X is mu is actually here, means like x that I have written is mu, okay, actually that is 3, and you have to put different value of x actually, okay, like that. Around this estimates at x equals to 3 means it is actually the mu, okay. Okay, and these xi values are the these values, okay. Okay, so any doubt?
Sir, but
When
x equals to 3 means it is mean. Now you have written here 5 somewhere in this equation by your pen. This is for the number of I equals to 5 here. 5 here.
Hmm.
So we can take this by 5, this
Hmm.
equation 1 by root 2 multiplied by pi,
Hmm.
and e to the power exponential that by 2.
Hmm.
Then again the whole is again multiplied or divided by 5. तो
Yes.
इधर सर जो है x इक्वल टू 3 डाला गया है, इसको आप बोल रहे हैं एवरेज, मीन बोल रहे
It
हैं.
is the mean actually. Yes.
और नाउ दिस मीन वैल्यू हैज टू बी पुट
I
इन
have
दिस
put it
वैल्यू
already.
3.
Hmm.
ओके, हाँ हाँ, अंडरस्टूड.
so when we will calculate all those values, after that we need to multiply it by 1 by sigma 2 pi. We need to put the value of pi also, 22 by 7 or 3.14.
Yes, yes. Yeah, I missed it. Okay, sorry. Yes, this one is also there. Yes, yes. Sorry. So this one has to be there as well.
Hmm.
Okay. Okay. So nothing more actually. We are actually done here today. No more questions left actually. We have discussed
थैंक
everything.
यू सर, थैंक यू.
That's all for today, sir.
Yes, nothing left till week 3. Actually, in previous class we did a lot actually. Week 2 as well as week 3 we covered. Okay, so nothing left now. Actually, I struggled to find questions extra. Okay, these are the questions I got. No more for now because the weeks have not been published. Means have not been opened. The week 4 and 5. Okay, if they have
Sir, can you explain question number 6 of week 3 assignment?
question number 6. Let's see. Old one and a new one maybe. Question number 6.
6. Yeah.
Acha, I think we did this one, I think, previously, but no problem. Okay, I will explain it again because we have time. So solution, I have kept it somewhere. So this is all right. We use the same slides again. Mm. So as you see, what we have done is that, so x is a discrete probability mass function. Okay, there are 10 observations. These are the observations, we need to find the maximum likelihood estimate. So what is maximum likelihood estimate? It is the product of, okay, so it is the product of occurrence of every sample. As you can see, probability is the it is uh, let's download this one. Maybe I have already. What I'm looking for. Hmm. This is the one, right? So likelihood is the joint distribution of all these values, all these x values. Okay. So as the x values are independent of each other, so we can write it as the product of probability. Okay, clear? You can write it as px1 px2 to pxn. Okay.
Okay.
So as you can see, okay, so you have to product every one of these. Okay, so starting with 0, how many zeros do you have? 2. Okay, so probability of occurrence of 0 is 2 theta by 3, so 2 theta by 3 square. And for 1 it is 3 1. Okay, so cube is will be there. Okay, and occurrence of 1 is theta by 3. For 2, 2 1 minus theta by 3 square. For 3 is 1 minus theta by 3 square. So this is the likelihood. How are you going to maximize this one? Have you been able to reach to this point?
Sir, how that comes in power 2, 3, 2, 2?
Because just see this one, that 0 two times, right? So
Okay.
0 first one will be written, the 0 second one will be again written, so I can club this to a square. Okay.
0 is 2 times, so 2 theta by 3 square.
Yes, as you can see
And
this. Yeah,
1 is
okay,
also
let
3
me write
times,
it
so
down.
theta by 3.
So what I'm trying to say is that p0 will come twice. Okay, so I
Okay.
can write it as square of p0. Okay, without writing two times. Okay, that is what I have written. Okay, so you understood up to this point? Okay, clear?
Okay.
Clear na? So now we need to take the derivative. Okay, may not be easy as well. Okay, so how am I going to do? See that. Okay, so what I'm going to do is first take the logarithm of the logarithm of L. Okay, why? Because it is easier to take derivative. Okay, logarithm is an increasing function, so it does not change the way the function behaves. Okay, so 2 log 2 theta by 3. Okay, next is theta by 3, 3 times. Okay, so 3 log theta by 3. Okay, next what I'm going to do is 2 will come ahead, 2 will come ahead, log of 1 minus theta 2 times by 3. Next is 2 times log of 1 minus theta by 3. Okay, this is the one, right? So next what we want to do is insert a slide. Okay, okay, so we need to take the derivative. Okay, so for
2 log 2 theta 2 3 2 2.
hmm,
How that comes like
log,
before?
that power comes forward.
Oh, yes, yes. Okay, okay. Log m raised to power n is n log m. Okay.
Yes, so take derivative of log, that will be 2 theta by 3. Then the chain rule derivative of theta will be 2 by 3. Okay, you can cut the coefficients, so 2 theta. Okay, next what you get is this one will become 1, 3 will go away. Okay, so 1 by theta will be left in below. Okay, so acha, below it is there, right? I got it wrong. So
2 by theta.
2 by theta, correct. So this will be 2 by theta. Okay, next is 1 by theta, I think. 3 by theta. So next one will be 3 by theta. Not able to write it very properly. Let's try again. Next what we have is that this will come below, and then taking derivative, minus will come out. Okay, okay, so it will be minus 2 by 1 minus theta, or you can write it as 2 by theta minus 1. This is 2. Let's correct again. Okay, next you can see it is what will happen. So 1 by 3 will go away. Okay, and it will become minus 2 by 1 minus theta, or 2 by theta minus 1. Okay, so it will be 2 by theta minus 1, you can write it 4. Okay, this what you can write is 5. This you can write as 5. Okay, we equate the derivative to 0. Okay, so 5 theta minus 5 plus 4 theta equals to 0. So theta is equals to 5 by 9. Okay, let's see the answer. Maybe I got it wrong, but the method will be like this. Answer you will get, but I made some calculation error here.
Sir, we will get the solutions of the assignments also, no?
Yes, yes.
So
Method will be
when
like this. You can figure out what I did wrong. Should be correct actually. 2 log of 2 by 3. 3 comes out
Last
2.
part, I think that 2 log 1 minus theta by 3. That I think that has to be checked.
Acha.
I think it is minus, I don't know. The last part should be minus 2 by theta minus 1. Maybe I'm wrong. I don't know.
Let's see.
I have to see.
So we take the derivative, and minus comes out. Acha. Minus comes out then, but I will reverse this order as well. 5 and 4, 9 theta is equals to 5, or maybe have they have answer approximated as 10, so that becomes 0.5. This can be one. 0.5 is an option. Okay, maybe like that. Not I don't know the answer actually. Answer, you know what is the answer here?
I don't know.
Then acha. Okay, what I think, like 9 can be made 10, so 0.5 closest answer. Okay, okay, any more problem? Any more issue? Any doubt?
no, sir. When we will get the solutions of all the of first two assignments?
Well, I'm not sure actually. The professor will release. I don't know
Okay.
about that, but you'll get it the answer. I'm sure of that.
And in the exam also, we will expect the questions like these only.
Like this only.
Okay.
Any more problem?
No, sir.
Okay, thank you very much, everybody.
Thank you. Thank you.
We'll be closing now. Okay.
Thank you, sir.